What will power our future? How will we store and transport this energy effectively and efficiently? These are the pressing questions of our time. As we stand on the precipice of a new era in energy consumption, the answers are not as clear-cut as we might hope. The challenges we currently face are enormous. Our traditional methods of energy storage and transportation are falling short in the face of increasing demands and environmental concerns. The batteries that power our devices and vehicles are inefficient, often wasteful, and pose their own environmental risks. The pipelines and grids that deliver our energy are aging and vulnerable. Enter the concept of supermaterials, substances with properties that seem almost magical. They're lighter than air, stronger than steel, and have the potential to revolutionize how we store and transport energy. Could these extraordinary materials hold the key to a new era of energy efficiency and sustainability? Could supermaterials be the answer to our energy storage and transportation woes? Scene script. Imagine a material stronger than steel, more conductive than copper, and as light as a feather. Welcome to the fascinating world of supermaterials. These are not your ordinary materials. They're extraordinary, possessing properties that surpass those of conventional materials we've grown accustomed to. Supermaterials are a testament to the relentless progress of science and technology, pushing boundaries and redefining what's possible. Take graphene, for instance. This supermaterial is a single layer of carbon atoms arranged in a two-dimensional honeycomb lattice. Despite being just one atom thick, graphene is about 200 times stronger than steel by weight. It's also an exceptional conductor of heat and electricity, surpassing even copper. And if that's not enough, it's nearly transparent and incredibly light. Another supermaterial that's causing a stir in the scientific community is carbon nanotubes, often referred to as CNTs. These are essentially rolled-up sheets of graphene, forming a tube that's only a few nanometers in diameter. That's about 50,000 times thinner than a human hair. Despite their minuscule size, CNTs are incredibly strong, lightweight, and highly conductive, making them ideal for a wide range of applications. But what really makes supermaterials like graphene and CNTs stand out is their potential to revolutionize various industries. From energy storage and transportation to electronics and medicine, these materials could open up new horizons for innovation and efficiency. Imagine batteries that charge in seconds or electric cars that are lighter and more energy efficient. Picture ultra-thin, flexible electronics or medical implants that can monitor and treat diseases at a cellular level. These are just a few possibilities that supermaterials could bring to fruition. The potential applications of these supermaterials could be limitless. As we continue to explore and understand these materials better, who knows what exciting breakthroughs lie ahead? The future of supermaterials is a thrilling subject, and it's one that we're just beginning to scratch the surface of. So, buckle up for this scientific journey as we delve deeper into the world of supermaterials in the next scenes. Imagine charging your phone in seconds or powering your house with a battery the size of a book. Sounds like science fiction, right? But with supermaterials, this could become our reality. Let's delve into how these extraordinary materials could revolutionize energy storage. Energy storage has always been a challenge. Traditional batteries degrade over time, they have limited capacity, and they're not so great for our planet. But supermaterials like graphene and carbon nanotubes could give us the edge we need. Picture a world where batteries are no longer a limiting factor, where your electric vehicle charges in the time it takes to grab a cup of coffee, and it can take you across the country on a single charge. That's the promise of supermaterials. Graphene, a single layer of carbon atoms arranged in a two-dimensional honeycomb lattice, is one of these supermaterials. It's incredibly thin, but it's also one of the most conductive materials known to man. This means it can charge and discharge electrical power rapidly and efficiently. Imagine the potential. Then there's carbon nanotubes. These tiny tubes are made of carbon atoms, and they're just a few nanometers in diameter. But don't let their size fool you. They have extraordinary thermal and electrical properties that could make our batteries more efficient, more durable, and even safer. Capacitors made from these supermaterials could store huge amounts of energy. They could charge in seconds and discharge without losing capacity over time. This could make them ideal for use in renewable energy technologies, where storing excess power is a major hurdle. And it's not just about making better batteries. Supermaterials could also make energy storage more sustainable. Graphene and carbon nanotubes are both made of carbon, one of the most abundant elements on Earth. This means we could create high-performance batteries without relying on scarce and environmentally damaging materials. But this is just the tip of the iceberg. The potential applications of supermaterials in energy storage are vast and varied. They could truly revolutionize the way we store and use energy. Supermaterials could usher in a new era of energy storage. Imagine a car that's lighter, stronger, and more energy efficient than anything we've seen before. A tantalizing thought, isn't it? That's the potential of supermaterials in transportation. Let's start with graphene. This single layer of carbon atoms, arranged in a two-dimensional honeycomb lattice, is incredibly light, yet stronger than steel. When it comes to electric vehicles, or EVs as they're commonly known, weight is a critical factor. The lighter the vehicle, the less energy it needs to move, and the more mileage you get out of your battery. Imagine the possibilities if we could replace traditional materials used in car bodies and components with graphene. We'd have vehicles that are not just lighter, but also incredibly durable. But the benefits of supermaterials in transportation don't stop at weight reduction. Another key feature is their exceptional electrical conductivity. Take carbon nanotubes, for instance. These cylindrical carbon molecules exhibit extraordinary thermal and electrical conductivity. In an electric vehicle, this means faster charging times and more efficient energy usage. Now let's consider aerogels. These lightweight materials have been dubbed frozen smoke due to their ethereal appearance. Despite their ghostly looks, aerogels are solid and incredibly strong for their weight. In the transportation sector, aerogels could revolutionize insulation, leading to better temperature regulation in vehicles and potentially reducing energy usage even further. Imagine the synergy of these supermaterials working together in an electric vehicle. Graphene for a lightweight, durable body. Carbon nanotubes enhancing battery performance and efficiency. Aerogels providing top-notch insulation. This could be the formula for the most energy-efficient, sustainable vehicle ever conceived. But it's not just about cars. Think about planes, trains, and ships too. Supermaterials have the potential to revolutionize all modes of transport, making them more efficient, more sustainable, and yes, even more exciting. We're standing on the precipice of a new era in transportation, one where the vehicles we drive and the ways we travel are transformed by the extraordinary properties of supermaterials. Supermaterials could redefine what's possible in transportation. But like any groundbreaking technology, there are hurdles to overcome. As we delve deeper into the world of supermaterials, we can't ignore the challenges that lay ahead. The first of these is production. Creating supermaterials like graphene and carbon nanotubes requires high precision and a controlled environment. It's a bit like baking a cake, but instead of flour and eggs, you're working with atoms and molecules. The process is intricate, to say the least, and currently it's not easy to produce these materials on a large scale. But scientists are tirelessly working on it, experimenting with different methods and techniques to make the production of supermaterials more feasible. The second challenge is cost. As you might expect, producing these supermaterials isn't cheap. They are, after all, composed of tiny, individually manipulated atoms. However, as with many technologies, the cost has the potential to decrease over time. We've seen this before with solar panels and electric vehicles. Initially, these technologies were expensive and out of reach for many. But as production methods improved and demand increased, prices dropped. So, what does the future hold for supermaterials? Well, ongoing research paints an exciting picture. Scientists around the globe are exploring new applications for these materials, from energy storage and transportation to consumer electronics and even space travel. Imagine a world where our cars, phones, and homes are powered by super-efficient, super-durable batteries made from supermaterials. Or a future where electric vehicles are as common as the smartphones we carry in our pockets today. They're lightweight bodies made possible by the strength and flexibility of graphene and carbon nanotubes. The possibilities are as vast as they are thrilling. The challenges? They're substantial, but they're not insurmountable. With continued research and innovation, we could see a future where supermaterials become as commonplace as the materials we use today. The journey of supermaterials is just beginning, and their future looks incredibly promising. Supermaterials could hold the key to our future, but there's still so much to learn and discover. Today, we've just scratched the surface of their potential in revolutionizing energy storage and transportation. Imagine a world where electric vehicles are as common as the smartphones we use today, all powered by supermaterials like graphene and carbon nanotubes. But this vision isn't just a dream. It's a potential reality that scientists and engineers are tirelessly working towards. Yet, this is just the beginning. We invite you to keep exploring, keep questioning, and keep learning about these extraordinary materials. Their potential is vast, and by no means limited to just energy and transportation. They could redefine the fabric of technology as we know it, and you can be part of this thrilling journey. Join us on this fascinating journey into the future of technology by subscribing to the Brainiacata channel. Stay curious, stay informed, and as always, keep exploring the wonders of science. Let's take a moment to dig deeper into the world of supermaterials. We've only touched on a few of these revolutionary materials and their potential applications. But in reality, there's a vast universe of supermaterials out there, each with unique properties and potential uses. Take, for example, silicene, a single layer of silicon atoms arranged in a honeycomb structure, much like graphene. Silicene has shown promising potential in electronics due to its compatibility with existing silicon-based technology. Or consider aerogels, the world's lightest solid material, comprised of 99.8% air. Despite its almost ghostly appearance, aerogels have remarkable thermal insulation properties, making them perfect for use in space exploration and building insulation. And let's not forget about metamaterials. These are artificially structured materials designed to control and manipulate light, sound, and many other physical phenomena in ways not possible with natural materials. Their potential applications range from super lenses that can see smaller than the wavelength of light to invisibility cloaks. This is just a glimpse into the vast world of supermaterials. The more we research and understand these materials, the more we can harness their extraordinary properties to drive innovation and create a sustainable future. That's it for this extra scene. Remember, the world of supermaterials is vast and ever-expanding. Stay curious and continue exploring. Now that we've delved deeper into the world of supermaterials, let's cast our gaze forward and explore the future of these remarkable materials. What does the future hold for supermaterials? Well, as science and technology continue to evolve, we can only expect more groundbreaking discoveries and applications. Imagine a future where our transportation systems are powered by energy storage devices made of supermaterials, providing unparalleled efficiency. Or consider a world where our electronics are no longer limited by the constraints of traditional materials, but are instead powered by silicene, offering unprecedented speed and power. Picture buildings insulated with aerogels, dramatically reducing energy consumption. And envisage a world where metamaterials manipulate light and sound in ways previously thought impossible. The possibilities are truly endless. However, while the potential of supermaterials is immense, it's crucial to remember that the journey to this future isn't straightforward. It will require continuous research, investment, and a commitment to overcoming the challenges that lie ahead. But, as we've seen, the rewards could be transformative. So stay tuned as we continue to explore this exciting frontier in the world of material science. That's it for this scene. Remember, the future of supermaterials is as thrilling as it is vast. Keep exploring, stay curious, and continue pushing the boundaries of what's possible. Welcome back, fellow explorers of the supermaterial frontier. As the future of supermaterials unfolds, it's crucial to address the elephant in the room, the challenges in the production of these materials. From the high costs of manufacturing to the technical complexities involved in mass production, these obstacles are not to be taken lightly. However, with the rapid advancements in technology and the persistent efforts of scientists worldwide, these challenges are being tackled head-on. We're witnessing innovative solutions like cost-effective production techniques and the use of AI in material synthesis, bringing us closer to a world where supermaterials are the norm, not the exception. But it's not just about overcoming production challenges, it's also about understanding the impact these materials have on our environment. While supermaterials promise a world of energy efficiency and technological advancements, we must ensure this doesn't come at the cost of our planet's health. Fortunately, many supermaterials are being designed with sustainability in mind. For instance, graphene, a supermaterial, is recyclable and has potential applications in water purification and renewable energy sectors. So, as we journey into the future of supermaterials, it's important to remember that this voyage is not just about discovery and innovation. It's also about responsibility and sustainability. So, let's continue to explore, but let's do it responsibly. Keep pushing the boundaries, stay curious, and join us as we venture further into the intriguing world of supermaterials. Welcome back, dear explorers of the supermaterial universe. As we continue our journey, let's delve deeper into the role of supermaterials in sustainable development. The promise of supermaterials isn't just about energy efficiency and technological advancements. It's about creating a future where sustainability is woven into the fabric of our lives. Supermaterials like graphene, with its recyclable nature and potential applications in water purification and renewable energy sectors, are leading the charge in this direction. But the potential of supermaterials doesn't stop there. They hold the power to revolutionize other industries too. Imagine the world of construction with supermaterials that are stronger and more durable than anything we've known. Or the medical field where biocompatible supermaterials can be used to create high-performance medical devices and prosthetics. The possibilities are endless. As we uncover the potential of supermaterials, we also uncover the potential of a brighter, more sustainable future. So let's keep exploring. Let's stay curious and let's continue to learn. Because every discovery, every innovation brings us one step closer to that future. Stay tuned for more exciting insights into the world of supermaterials. As we wrap up our discussion, let's take a moment to contemplate the profound implications of the supermaterials revolution. The journey of discovery and innovation is far from over. Continued research and development in the field of supermaterials is crucial. The more we learn about these materials, the closer we get to fully unlocking their potential. Imagine a future where the clothes we wear, the buildings we inhabit, and the gadgets we use are all enhanced by supermaterials. These materials could change our lives in ways we can't even begin to comprehend right now. Take, for example, aerogels. These supermaterials, with their ultra-lightweight and incredible insulating properties, could revolutionize everything from our home's insulation to the protective clothing of firefighters. Or consider metamaterials, whose unique properties could one day lead to the development of invisibility cloaks. The potential impact of supermaterials on our daily lives is not just about futuristic technologies or energy efficiencies. It's about improving the quality of life, promoting sustainability, and opening up new possibilities for human advancement. Thank you for joining us on this fascinating journey into the world of supermaterials. Remember, the future is not set in stone. It's a canvas waiting for us to paint with our innovations and discoveries. And supermaterials might just be the paintbrush we need. So stay tuned, stay curious, and let's keep exploring this exciting frontier together.